So, hi everyone, I'm Lisa Wolfigel. I'm what we call the Partner Cloud Solution Architect in Data and AI within Microsoft Switzerland. And my role in Microsoft is to support partner to like a system integrator, but also software vendor to understand the new services that are developed by Microsoft in the data and AI section, and to make sure that they can play with it and integrate them into their solutions. So today we are really going to can you still see my screen? Normally you're supposed to see the agenda, but definitely it doesn't want to work. So in the presentation, so like the 15 to 20 next minutes, I will give you an overview of why customers and organization are modernizing the data platform. And then we are going to talk about the different stages of migration and modernization, and a quick overview of the different services that exist in the Microsoft ecosystem. So too bad for you, you didn't get the agenda, but you will understand it throughout the journey. So the first one is why organization are modernizing data platform. And it starts with the fact that data is coming from a lot of places. And even if you know that you need to invest in data platform, in analytics, you still have this kind of challenges about data are siloed. They're in different format. It's changing a lot depending on the business. Most of the time, it also depends on the people you have inside your company. If you have like a data engineer or data scientist, you're not going to play with the data in the same way. And also you have the issue with the total cost of ownership and the capex and all of this. So control, there's also more security threats. So overall, they're still the same challenge that we have for the past like 15, 20 years. Even today, we still have the same challenge, and we are trying to move and modernize the solution. And so there are what we call this migration triggers, sorry. So most of the time, organizations are willing to migrate and modernize because of these different triggers. So you have either your data center contract that expire, or you want to move from capex to a pay-as-you-go OPEX. There is more and more security, so you want to have a better security posture. So that's why you think about migrating to the cloud. Or you have different budget and resource constraints. So this is all about migration, but obviously also the remote working way these last few years have been also a trigger to migrate to clouds and to modernize that application. So all of these to say that challenges are still here, and I know Peter will also talk about other challenge, so I won't spend too much time on this. But there is a real need to go from on-prem to cloud, whether it is private or public. So now that you understand like the different trigger, you need to also understand the different stages that exist in data platform modernization. And it all starts about the discovery. So first of all, you want to understand your total data estate environment, the different workloads that exist, how big they are, how frequent they're used, and how they are used. So you really want to have this big overview of all your data within your organization. And once you've done this discovery, you start by assessing. So really putting some measure on it, like about the frequency, having this prioritization, list, and really have this this view of which service might be used in the cloud to replace or enhance a specific application and a workload. And maybe you want to think at this stage about the mitigation when you are doing the migration, and if there are some links between some database and infrastructure that you want to make sure you write it down and you know about it. Once you've done all of this, you start by doing your plan on we are going to start by migrating this application, and then this one, and then this one. So really setting up the priority, the order, and which services you're going to use in the cloud. And then in the transform and optimize, you are actually doing the migration and doing some improvement. And the last phase is where you're validating your migration is working well, and you remediate to any issue that arise in the meantime. So just before talking about the different solutions that exist in Azure to do all this migration and modernization, just want to drill down a bit in the planning phase, which is where you're actually going to think about the different applications you have, the different workload, the different way you interact with your data, and think about, okay, how do I migrate, but how do I modernize it? And there are these 7 terms in the planning phase. So the first one is remain, which means actually you do nothing. So you modernize the application you have on-prem, but you don't think about, or you think about, but you don't actually act on migrating to a private or public cloud. And then you have rehost and refactor, which are where you're gonna actually migrate to the cloud in IS mode, so infrastructure as a service. And this is where you're gonna reduce the total cost of ownership really here, because you're removing all the data center management from your end and shifting it to the cloud provider part on the data center and the hardware part. So this is where you rehost or you refactor, so you change some of your code. And the next step is you can also re-architect your solution to use some of the capabilities that we have in PaaS, so in platform as a service. And really here is about like changing some of your code, using some new services, so you can even rebuild some application from scratch using PaaS, so using more solution from the cloud provider, whether it is high availability, it could be auto patching. So there are a lot of capabilities that are managed by the cloud provider that you can think of. And the last 2 one are replace. If you can totally change from your application on-prem to a SaaS solution that will do the same business use, but with different services, or you can retire some application that needs decommissioning. So, and sorry that I'm rushing, but I know Peter has a lot of stuff to say, and I think it's better we focus on his part. So I'm just trying to kind of inspire you and to give you this foundation of the migration, the modernization, and now we are gonna go into the different solution that we have within Microsoft. So within this big Microsoft ecosystem, and the different solutions that we have. And the first choice is what we were just mentioning before, is a choice between the platform target options, which would be either IS, infrastructure as a service. This is where you're gonna be able to move your SQL tables, your SQL server into a SQL server that is hosted in a virtual machine. This is on the IS part. If you want to remove the overhead of the management, you can go more and go in the PaaS section. And there you can use SQL Managed Instance, you can use Azure SQL Database. If you have MySQL or PostgreSQL, On-Prem, you can also use Azure Database for MySQL and Postgres. And if you want to go even further, so if you want to have uh, Power BI, if you want to extend with machine learning, if you want to extend with analytics, then there are other services like Azure Machine Learning and Azure Synapse Analytics that you can think of. And right now, I just want to focus more on the SQL family. And the SQL family, there are different options depending on your use case. If you want to do a lift and shift of your workloads and you require OS level access, then your solution is for a SQL Server on Azure Virtual Machine. If you want to modernize existing application and not changing much of your code, but still use all the past advantage that you have on high availability, auto scaling, and stuff like that, you can go with Azure SQL Managed Instance. So you kind of get both the good part of both worlds, you know. So like you still are in control of a lot of your instance, of your pools, but you have also access to some of the stuff that we are managing on the Microsoft side. And if you're actually creating new modern clouds app, the best is the Azure SQL database directly. And if you go into the Edge section, then you have Azure SQL Edge, where you can do IoT with dedicated database with SQL. And what you see on the bottom side is Azure SQL is enabled on Azure Arc, meaning that if you want to have a hybrid setting with on-prem and even multi-cloud environment, not just Azure but other cloud as well, it is possible to enable Azure SQL with Arc. That's another topic. And we know that it's kind of complex to know which offering is right for you. So that's why we have this kind of layout. If we start at the bottom, let's say you need OS level access, you need some capability to tweak the virtual machine, then you should go with the SQL Server on Azure VM. And again, this is really good when you want to lift and shift, not do a lot of refactoring, just move your workload as easy as it is. And if now you need to have the same on-prem SQL Server compatibility, and if you want to have like a special VNet for security that is created for you on the cloud, then you can use the Azure SQL Managed Instance. And you can see on the right side the benefit of the past, so like lower administrative burden, dynamic resource scaling, all of this, which are part of both SQL Managed Instance and SQL Database. And so the last one is mostly when you're creating new app, so really app innovation. Therefore, Azure SQL Database would be more suitable for your need. So that's what I wanted to show in terms of SQL family. But now let's say you want to go further and moving your data warehouse into the cloud with the SQL database is one step, but now you want to go further. You want to add analytics and you want to unify your hybrid enterprise data estates with analytics. So the solution that we have is Azure Synapse Analytics. And really, this is the platform that helps you to do big data warehousing, and data integration in a single cloud, in a single platform. And Datavault Builder is also based on Synapse and moving on Synapse. And I think Peter will show it to you later on. But basically, if you have a lot of data, and if you want to do a big data analytics on this data, if you want to unify all of this is the right platform for you. So really having this data warehouse on the cloud. And here in this view is just for you to understand like the different capabilities that exist in Synapse. So within Synapse, you have already all the part on data integration. So you have more than 100 connectors from on-prem applications, streaming data, different clouds that you can use to import the data into Azure Synapse and do all the ETL and ELT process in a either code or low code or no code experience. So you really have within Synapse Studio all these different experience depending on if you are a developer or more data analyst or data scientist user. You have everything for you. So you have notebooks, you can do machine learning on Azure Synapse Studio directly. You can connect Azure Synapse to different solutions like Power BI and Power Apps, and you have different engines. So you have SQL and T-SQL, and you also have Apache Spark to do your analytics. So just for you to understand a bit, and within Synapse, you also have Azure Purview for data governance. So all of it is kind of packaged together for your data warehouse. And my last 2 to 3 slides are about like what is ahead. And right now, we've seen and a lot of interest in Synapse. It's working great, and we want to go even further into unifying every people in the company that is working on data within the same platform. And that's what we had with previously what we called the Microsoft Intelligent Data Platform, which was a way to kind of package all of the solutions that we have, whether it was on a database like SQL, Cosmos DB, or with Synapse Analytics, so more on the big data analytics, on the data warehouse. We had Power BI, Microsoft Purview, all of this was really packaged in what we call the Microsoft Intelligent Data Platform to have a unified way to deal with data. And we now continue this vision. We just introduced Microsoft Fabric, and it really goes into the same idea of packaging more and more all the different services, because we know it's super hard to integrate all of the services when you have data integration at some point and some machine learning there. And really what we want to have with Microsoft Fabric is to have this end-to-end analytic platform where you can do everything, and everyone who is dealing with data should be in the same platform using the same data foundation, which is one lake. And Fabric is seen as Microsoft 365. So in Microsoft 365, you have OneDrive. This is where you have your data that you use to create your Word, to create your Excel file, your PowerPoint file. And this is the same for Fabric. We have one lake, which is kind of the same as OneDrive, but for all analytics. So all the data is in one location, in a Delta format, in a Parquet format. And from there, you have different user experience, either data integration or data engineering or a data scientist. Or data analyst with Power BI. So you have all these different persona user experience that are delivered in a same analytic platform. And this is more like a SaaS platform rather than a PaaS platform, which was before Synapse and all of this. So that's the almost end of my presentation. My last slide is on the business outcome you can expect when you are migrating to the cloud and modernizing your infrastructure and your data estate, is that we've seen 77% increase in revenue for organizations that succeeded to migrate and modernize their analytics platform on the cloud. We've seen 81% on operational efficiency, 70% on market share, and 77% on customer loyalty. So there is a real impact on business when you think about moving to the cloud, migrating, and modernizing your data estate. And on this, I hope, Peter, you still have enough time for your presentation. So I'm leaving the floor to you, and sorry again for all this mess on the technical part.
Thank you a lot, Lisa. So thank you as well for the introduction. And I need to reclaim to be host. Hopefully grant me that.
Yeah.
So I can share my video. So I will pick up where Lisa left off. So all these Microsoft products, they have different benefits and features, and most probably you will grow with the different product lines and end up at the end in the cloud. So I will pick it up from there and explain what we are adding to it. Let me share my screen. I'm working for the company Datavault Builder, and the Datavault Builder is our software product that we're producing. We're located in Zurich. We have now a resource pool that we can access with our implementation partners of over 130 resources. And the main development is happening here in Zurich. That's as well where I'm located. We have more than 180 installations worldwide and many implementation partners serving our clients. So what is the issue we're addressing? And our clients usually don't have the issue that they need to look for data. They have a lot of data, but it's spread over different source systems, maybe different cloud services. They maybe get data from external providers like their suppliers or their customers, and they need to bring all the data together to service their data consumers, which can be internal departments or can be as well external consumers like legal reports, but as well suppliers and customers again. And they need to do this regularly. They need to deliver it in a good quality. They need to deliver as well the information where the data is coming from, especially in Europe with GDPR. We need to always deliver the report, how the data lineage looks like. And to service all of these needs is very, very difficult. So when I started back in data warehousing, it looked a little bit like this. So we had many different tools, many different interfaces between them, and we had many big teams. And it created a lot of cost, a lot of delays, and the data consumers were never happy. They always waited for their data to get it. So just to have a database doesn't help. You need to have a process, how you integrate data, how you document the integration, how you run your integrations. And this is exactly why we have created the Datavault Builder. It replaces up to 9 different tools and solves everything from developing in this area to deploying, to reporting of all the operational tasks, to running your jobs, and solves everything out in one solution. And why does this work? Because we start usually with the business model, and we bring together different groups in the company, the business users and the IT people. And in the past, they sometimes had communication issues because they had different interests and different language. And so the data model becomes a unifying factor in this approach. And this was tried in the past, but in the past, we created this kind of data models and we printed them out, handed it over to the IT people, to the data engineers, and they started implementing, and for good reason, sometimes implemented different stuff because the data model that the business was believing is true was compatible with the data that was in the system, so they needed to change stuff, but never reported back what the data model was really. And the business users didn't profit from it because they never got this information back. They just participated and then they didn't know what happened. So here we're creating the business model, and in real time, we're helping the IT by generating all the implementation in the database, creating the load processes directly based on the model. And for the business users, we deliver all the metadata and the real metadata because it was generated, what was implemented back to the business users into their report, into their Power BI report, so they don't need to switch between tools to see their data and to see the metadata and understand what a customer is, what the definition of a product is, why there are maybe 2 or 3 definitions of a product, depending on what you're looking at. And this means that we're creating this kind of models in the tool with core business concepts, relations, and in the background, it creates the implementation. But we don't stop there because, as mentioned before, we need to solve so many different things like infrastructure, like deployment. This is exactly why in the Datavault Builder, we have many different modules. So we start with infrastructure automation, and the Datavault Builder was created as a cloud-native tool, means we deliver you the software as Docker containers, but still this is a format that you can run on premises, and I will highlight that later. Then, as soon as your environment runs, you don't need to install it, you just start it up. You can start modeling, and it generates your code. So it generates tables in the different Microsoft products. It creates load statements, but at the same time, you can do data profiling in parallel without adding any effort. It's creating documentation and data lineage for you. Then it supports you in testing. So it has REST APIs to create a new environment, to load the data model, load the test data, receive the results of your test load, and validate or not validate your changes that you have done. And this is especially important if you do like agile development, if you do very often deployments, you need to automate this kind of tasks, otherwise you lose a lot of resources in here. The next step is that you need to deploy your data models between different environments, and in data warehousing, very often we see that you have maybe a development, test, and production machine. But with the Datavault Builder, deployment is so simple that you can extend it to even have sandboxes. So if you want to go in the direction of distributed development, means that you have one sandbox for every feature that you're developing, it allows you to do so. And this means that you can use the full Git flow-based process in your workflow. If you don't want to do that right now, that's fine. You can go for the simplified path, but you know that the tool supports it later. And this is as well cool then later on, if you're moving in direction of Microsoft Fabric, that it will be very, very simple later on by splitting up the storage and the compute parts, that you can create sandboxes later on, probably very, very simple. Now, the next step is that you want to automate this kind of deployments, because if you're deploying weekly or even daily or more often, you get tired of doing everything manually. So there are REST APIs for executing all these tasks automatically. So you can use tools like Azure DevOps to completely automate your deployment pipeline. The next step is that you want to run your jobs, and this is included in the platform itself. And here, some clients might decide that they want to use their existing enterprise scheduling tools like Chronicle, UC4, whatever. That's fine. We have REST APIs as well for that. Or if you don't have such a tool, you can use the built-in scheduler. Logging is automatically. We're creating all the job controls automatically. We're parallelizing for you automatically. So you just need to define what you want to achieve, and the tool will execute it for you. And if you want to go for high availability, we can show you how to run hot, cold standbys, blue-green deployments, stuff like that. And really along the full line, the tool is supported by REST API. So everything that we are doing in the tool that you can do by a click of a mouse button, you can do as well by REST call. So how does this run, and how does this interact with the different databases? So with the model-driven part, that is generating a core data warehouse that will persist your data, that will persist your business keys in so-called hub elements, that will persist your attributes and the changes in the attributes in so-called satellite tables and the relations in link tables. But you don't need to worry about that. You just need to worry that you know how your business runs, what is your conceptual, and what is your logical data model. The translation into the physical data vault, the implementation that we're doing in the database, is done completely automatic by the tool. After you define what your target model is, the next step is that you can use staging. And here we have a lot of built-in connectors to connect to different databases, to connect to NoSQL sources, Python scripts, REST APIs, Excel files. And this works very well. And you will use them most probably if you're using SQL Server on premises. We heard it before. If you're going in the direction of Azure, Synapse Analytics, you can use the built-in connectors, and we support that as well. So if you have the data already staged in Synapse Analytics, we have a ELT loader that picks up the data from there where it is, just does the calculation top of it that we need, and process it further. The next step is, after 1, we created the data model. 2, we created the staging loads. 3, we now link the stage data by defining so-called business keys to map it to the data model. And we can map different data sources to the same elements by defining the business keys coming from different sources to the same conceptual element, and we will create automatically the integration between the systems. The next thing is that you have staged your data, you have persisted it, you have historized it, completely automatic based on the model, and now you want to retrieve it. And when I started in industry, there was like this discussion about golden records, one truth, and it turned out that it's not that simple. Yes, we have here a unique source of facts where we store everything as it comes from the source system because the consumers sometimes have different views. Imagine that you have maybe a sales department, they don't want to see any orders with the value of €0 because they would destroy their margins because there are maybe samples that are sent out. But the logistics need the same view about orders, but including this sample send-outs because it's changing the stock that they have. So here you can create many different interfaces, you can create different formats, even on the same element. So if you are like using Power BI, most probably you will create your dimensional model. If you want to distribute the data in receiving applications, maybe Microsoft CRM, you can create your third normal form model. If you want to use any of the AI ML applications, you will maybe create your flat table output, or if you're going more in the direction of data mesh, you can create your data product. And as well here again, here I'm really happy as soon as Fabric's release, we will have a cool opportunity that we have many different systems for the different data domains publishing into the same lake, one lake, and then you can use Power BI to report all over the different data products you're receiving from your different data domains. Now, the next step is that we need to publish this to data marts, or because we stored here all the data, and that's a big change from classical data warehousing if you're still looking like at Inman data modeling, that we didn't sort it out the bad data here. So we have it here, and we can now decide if it goes to the data marts or if it goes to so-called error marts and will be reported to the data stewards. And everything from staging downstream always, and sometimes as well the staging itself, is handled by the database. So we are mainly a ELT tool, and that's why we're relying on very good databases, and that's why we're so happy to working with SQL Server and with Synapse Analytics. So a little bit, which kind of work can be done with that? We have clients like eGym, they're producing this kind of machines for gyms. They're collecting a lot of data points. So every push-up you do, collect a data point. They're doing analytics on what should be your next exercise, on how the machines are used, and what you can improve. And they're doing all of this by just having a data team of 2 people, not only doing the data integration work, but as well doing the reports, as well doing the support of the internal consumers. On the other side, we have clients like ProSieben in Germany using that on a bigger scale, having different data teams, doing data integration in the cloud, now with distributed development, using sandboxing approaches, and that's all possible with the Datavault Builder. So why do people use the Datavault Builder? It's for many people to save time during development. And we have here the slide up to 90%. I just did last week a webinar with a big Ivy League university, and they've really calculated the time not only in development, but overall in the project. And they were saying they saved, including analytics of the data sources, 70% of the whole time of the project by using this automation approach. And this is an important point, but I think as well important is it's reducing your risk. You know that so many people are using exactly the same approach. They did it before. It's a standardized approach, so you know that the chance to fail is much, much lower than if you try to do something manually or new. And it will lower your maintenance cost over time because you can take the same solution and deploy it on different platforms, and that's what I will show you in the next step. And as well, over time, we're delivering you updates of the patterns and of the physical implementation, because SQL Server in the past, now 11 years that we support SQL Server, evolved a lot. So there are new ways to using the database that wasn't possible before. And if you create your solution yourself, you need to update your physical implementation as well yourself. If you have an automation tool like ours that is standardized and delivers the patterns with it, you can use that to update your implementation automatically. So what are we doing different than other tools? We are using a modeling interface and not against a repository like other tools and then maybe pressing a button and implementing it. But what we do is that as soon as you model something in the front end, in real time, it creates the implementation on SQL Server, on Azure Synapse Analytics, and it knows exactly in which points are different. There are minor differences, but still there are differences in permissions and how you distribute your tables and stuff like that. And we're abstracting that for you and creating the corresponding correct tables in the target platform. Now imagine that after you used automation to generate your objects, there might be like a production incident and you need to change something in your implementation. And this happens in the real world and it happened in all our projects. And if you would have like a repository in between and the changes happen here, probably somebody manually needs to transport these changes back to the model, and this seldom happens. So here we have built in a two-way synchronization. So as soon as you model something, it's created on the database. If you would change the implementation at the database level, the model is updated. This means that if you create a concept in your data model, in the exact same second, the object is created here at the database level. In SQL Server, we store all the metadata in extended properties. On Synapse Analytics and special configuration tables, these are like these minor differences that we abstract. You don't need to care about that. It's happening automatically in the background. And if you go in the database and change something, automatically the data model gets updated. So how does it look like? So imagine that you have like your data model, and today you're on premises and you have your SQL Server running, you generate your code. Later on, you decide that you like to move to the cloud. You consider first like running just the SQL Server on an Azure virtual machine. You figure out, I would need to do too much, but Microsoft is offering Azure SQL databases, so I can just use that and deploy my model now to that and migrate my data, and I'm good to go. Still, the front end behaves exactly the same. Everything is the same, and as we store everything in the database by just migrating over the structures, metadata, and data from one to the other database, the tool will connect again without any migration cost of the Datavault Builder itself and continue running. And maybe later on, you decide that you want to go serverless and that you want to use Synapse, that you want to maybe use Azure Container Instances to run the tool, and then you don't have any infrastructure to manage. So you have no Linux VM or servers or anything to run. You just rely on the service that somebody provides. So you will save cost by operating this kind of solutions. Now let's go a little bit in detail. So in the beginning, you might start with the SQL Server. Your Datavault Builder will most probably run here on a Linux virtual machine. Or if you have a local Kubernetes cluster, you could run it there. Second step that you would take is to move it to the cloud, but still relying on servers. As we had in the presentation before, it could be SQL Server running on a virtual machine on Azure, Azure SQL Database, or SQL Managed Instance. It really depends on how many databases you have, which kind of scenario that you have for your migration. But this lift and shift is pretty simple. And as well for the Datavault Builder, you would run that here on a virtual machine on Azure, which is pretty simple, or you can deploy here as well a Kubernetes cluster into your tenant and run it there. Now, the next step is to go from this instances still connected like to one server and go serverless. And here we go in the next kind of categories. We already support now with version 7 that will be released this week, Azure Container Instances. So really with one click, you can run the Datavault Builder without taking care of the operating system. We're supporting Kubernetes. So if you want to run a Kubernetes cluster with your Azure tenant, that's as well possible with one click. We're supporting already Synapse Analytics dedicated pools. We're preparing for Synapse then running on Fabric. And as well, what we are preparing right now together with Microsoft is to bring the Datavault Builder to the Microsoft Azure Marketplace, that with one click, you can deploy not only the Datavault Builder, but as well the database, so including the SQL Server or including the Synapse Analytics dedicated pool cluster with just filling out some parameters. And it doesn't matter if you don't think about this path right now, if you're right now here, but you have this like insurance policy that at any point in time, by just moving the structures and data to the corresponding cloud products, you will have no migration cost for the Datavault Builder because the tool itself is stateless. It stores all the database in its corresponding database. I would do like a quick poll, and just I would be interested, where in this journey are you right now? So we have here a short poll. If anybody likes to answer, I would be happy to that we see a little bit where we are. Yet I will close the poll. So we have 27% of the participants are still on premises, 33% are somewhere on the move, a little bit in the cloud, a little bit on premises, I assume. And we have already 40% in the cloud. I did this same kind of polls about 2 years ago, and in the cloud was below 10%. So we see already this tendency. So it's really important probably that even if you're not yet there, that you already think about at least that you have systems which are compatible, which are built for this kind of technology. Even maybe legal things can still block you to go there, or maybe company culture. That's fine. Everybody should take its time, but at least to have the possibility based on the architecture that you choose to achieve that. So how does the Datavault Builder look like? And I can't give you in the short session demo. I give you just a 5-minute introduction, just that you have the look and feel, that you get the first impression. So let's switch now just to my online environment. And we did start that here using containers just in a virtual environment. Within 2 minutes, it's just a startup command. Everything installs automatically. We used a data model we have stored in Git to deploy to our environment. And this is the layer where we are creating our conceptual model. So we have the blue boxes that represent people, tasks, events, or things. And herein we can create simply by adding new concepts, like if we need buses for our object, we can add it here. And in the background, in the same second, I'm designing this element. It's sending its command to SQL Server, and the database table in the background was already created and is waiting for its data. And this is exactly what we call really becoming agile. So in the moment you model something, it happens at the database level. So after creating here a conceptual and slowly go conceptual model and going slowly to the logical level by adding relations and describing attributes, grouping stuff into subject areas or data domains, we can now go in the next step, in step 2, and connect to the data sources. And this is happening in here. In the staging area, we have already imported here different connections, but here we have a list of many different connectors that we can connect to. And as mentioned before, if I'm on-prem, most probably I will use a lot of them to connect to my different data sources. If I'm then already on Synapse, I could use the built-in connectors and just use the intra/cross database staging module to trigger the built-in Azure Synapse connectors to pull the data in, and Synapse can spread it all over its nodes and use the full performance of Synapse. Now, the next step is that we go and as a third step, first step was the data model, second step was staging, step 3 is that now we need to connect the data from staging by defining a business key to connect data with our data model. And as soon as we do that, all the magic happens. So it will create the loads to load the business keys. It will create the satellites with all the attributes. It will load the data, including historization in here. It will do, as of now, query performance optimization, so you can access the data fast. It will create tracking objects in the background, so you don't need to check if some keys were deleted in the source. We do that for you. And it will adapt as well the ETL loads to pre-calculate certain stuff during staging. And this is all possible due to standardization. If you want to check the data after staging and before you load it in the core, there's a built-in as well data viewer to look at your data. And as soon as you have your data loaded in here and materialized, you can go to the next level and start creating here your interfaces as well. This is visual. So here you can create like your dimensional model for Power BI. You can create here as well flat tables for your Pandas data frames or whatever you're using. You can create third normal form for your Microsoft CRM recipients, stuff like that. You can as well manage your business rules in here. What is created in the background automatically is the data lineage section, so we can filter down on specific sections, visualize how the data is flowing. Operation is handled automatically. So if you look at something, this was never created manually, it is derived directly from the model. You can run jobs here directly, you can schedule them, and at the end, it creates for your documentation. And this is not a theoretical documentation based on your modeling, but this documentation is happening on what is really implemented, because this is the same. We don't have any disconnect. And the last step that you can take is that you can now take everything you created in your development machine or your sandbox, and you can start deploying it, comparing it against your test and production environment, automatically generate your deployment scripts, or export your stuff into Git. And if I say I can click here a button as well here, it means there's a REST API to automate this kind of process as well. So this was just a 5 minutes overview. If you're interested, you're really invited to book on our webpage one of our demos where we answer your questions within about 1 to 1.5 hours, go through all the modules, create how the implementation works, and that it usually takes about 10 to 15 minutes to create like your first, the well-documented, production-ready implementation pipeline. Good. So let's go back to PowerPoint slides. And now let's open the discussion for any questions, and not only to me. Lisa is still on the call, hopefully, and is happy as well to answer.
Yes, I'm still here.
Good. If you want to ask any questions, there is a Q&A button at the bottom. Just click it, and you can type in your questions, and we will answer them. So here's one for you, Lisa. So when do you think will this new Microsoft Fabric version of Synapse be available to the public?
So we're still, Fabric is a huge, I'm just gonna turn back my camera. I can still not, it's fine. So Fabric is a huge project, and we had people working on this for the last for the last years. And because, if you understood correctly, it's integrating a lot of product, it takes time to have it ready the way we want. So we hope to have it in general availability by beginning of next year, 2024. The release has been a bit delayed. It was supposed to be in November, I think. It has been delayed a bit, but the goal is really to have it ready for customer as soon as possible. So I don't have an ETA that I can share right now, like specific date, but nominee should be up beginning of next year.
From our side, we're closely monitoring, and we're trying as early as possible to use that technology, because I believe it's a great leap forward. It's really the separation, please, Lisa, correct me, of separation of compute and storage. And this is really a very nice concept. So you can have then as well compute clusters on top of it that can be scaled, that can be run on demand, stuff like that. And we're really looking forward to supporting that because it really supports architecture, how we want to work with the data.
Yeah, definitely. And it's really accessible for most of the people. We are trying in all of our vision lately, we are trying to make it accessible to more and more people, even people who doesn't have knowledge in data warehouse or SQL. The goal is to have this platform that BI analysts can just work on it directly and not have all the technical background necessary. So there is a lot of expectation on this product. So that's also why we are a bit long to deliver, but I think it's for the good.
And one more question: how can we try that out? If you are still on premises, as long as you have a Linux server that is installed with a distribution supported by Docker, you can install the Docker host and you can run a POC with one of our partners that will help you to connect it to your SQL Server database within a very short period of time. Usually the setup of the whole system takes about 1.5 hours. It can take a little bit longer if you have firewalls or proxy servers involved, but the installation of the software, in fact, is just downloading it, starting it, and it should run out of the box. Then you can run it with one of our partners. They help you start modeling, using it. And after about 1 week, you should be able to verify if it suits your needs. If you go to the Azure cloud, it can be even faster. You can just spin up like a SQL Server, a managed instance, or you can start Synapse Analytics just through your Azure portal. You spin up a VM or a Kubernetes cluster within Azure and deploy the Datavault Builder to it, which is really just a thing of configuration. And then with the help of one of our implementation partners, they will again help you to start modeling, define your success criteria, what your test should be, and run that test within a very short time.
Peter, I don't see the question, so if there are the question also.
Don't worry, I see it as host, at least. Good.
Good.
Okay, so I think we're reaching the end of the webinar. I thank everybody for the interest. Is there anything you want to add at the end, Lisa?
Nope, I think it was pretty clear, and I hope a lot of people are going to try out your solution, which is super cool.
Yeah, thank you as well. Always happy to work with you. Really, we have really great support. I think the product that we are using from Microsoft with all the SQL Server, I'm using it since version 2008, improved over time a lot. It's getting better and better. It's really something that you should try out. I thank you a lot.
Thank you all. Have a great evening or day, depending on where you are. Bye.